My name is Roger Philp. I work for Bain Core. It's an Intel professional services partner of Intel, rather, sorry. This is Manuel Fernandez. Another of our speakers will be here on Thursday, which will be Richard Paul. So this one is going to be, it might be slightly misrepresented in the notebooks, but it's actually about the Intel Media SDK and why it's of use to you. Okay, there's about 30 slides, but some of them I'm just going to simply skip over as everybody knows what I'm talking about, kind of thing. Okay. So let's do a bit of background. The Intel Media SDK, it comes as part of the Media Service Studio. It's a cross-platform application interface, and of course it's for developing things like consumer professional media applications, your obvious video editing, processing, meeting conversion, streaming, playback, and video conferencing. The kind of stuff which is very, very prevalent at the moment. And of course, we're going to get a higher and higher demand for this stuff as we require higher and higher resolutions on screens and so on and so forth and devices. The definitions then, just very briefly, we all know these pictures. What is media? Well, clearly it's going to be pictures, video, movie, and audio. The various types, the MP1, MP2, MP3. I don't know if anybody's ever, or like the video, if you ever dug through the headers from the MPEG stuff. It's more of a philosophy than a design specification. There are going to be obviously special considerations for media delivery over networks. Networks can be either fiber, copper, or radio. And there's going to be an increasing demand for high bandwidth requirements to try and eliminate things like jitter, reduce latency times, and of course loss during transmission. But one of the most remarkable things is that we've actually had quite a high-speed bandwidth across the world for 50 years now. Being TV, which has that transmits at roughly about a half a megapixel per second. Okay, the reason why we're looking at it is, why would a developer want it? Well, it's primarily because of this. This is I don't know which chip this is, but it's one of the core series, an i5 or an i7. It's also applicable to the Atom chips on tablets. And the reason this stuff is really applicable is because not many people seem to realize this, but the same piece of silicon actually has the CPU and also a graphics processor on it as well. Okay? And the Media SDK will allow you to actually directly access that hardware over here. So as I say, the Media SDK gives you direct access to the GPU. It allows developers to optimize for high definition standards, and I thought it was actually only available on the fourth plus generation Intel Core processors, but apparently it's on the second and third generation Core processors. It's also cross-platform, so the immediate question would come to mind would be, well, you know, if I've got a processor that's not an Intel Core type processor, how can I make use of this stuff? Well, there is actually inside the software libraries, you can actually substitute the hardware for software. Okay, it's there immediately, so you can just simply port it across to a different platform. The challenges of media is, of course, the sheer volume. Of course, then we've got an extra thing of screens in all sizes, and of course, resolution. The sheer volume, I'm going to skip over some of this stuff, is down to video on demand, TV, peer-to-peer video, and apparently the estimations according to markets, I can't even read that. I can't even read that either. It's going to go up to about 86% of global consumer traffic in 2016. And by that time, we're going to be looking at a vast amount of YouTube uploads, one of my favorite learning tools, and 6 billion hours of video watched per month, and that's an awful lot of EastEnders. Okay, so the estimated data transfer in terms of petabytes per month, this is based on numbers from 2011 going to 2016. Okay, they're estimates from 15 and 16, but it looks to me kind of like a quadratic curve. The only things of real interest, I guess, on these graphs are the mobile web data and the mobile video. And these things are increasingly important in terms of video streaming and certainly data streaming. As websites get more complex and people want higher definition resolution. Okay, screen resolutions. Again, that's another issue. I don't know if anybody's ever written a website using the CSS and having to take into account whether you're dealing with a mobile phone, for instance, or whether you're actually dealing with a main screen. That's always a pain to try and sort out how to set up the web page. But that's going to be increasingly important. Some of the following won't apply to individual users because it's simply not going to be reasonable to supply some levels of data to a home, for instance. Okay, so one of the then problems is the fact that you've got mobile device growth and you've got then connections, and the connection speed has, up till recently, begun to has not been keeping up with demand for devices. Okay, so I've expanded these graphs out a little bit. And again, we can forget some of these things, but we've got transition of data across non-smartphones. Obviously, there's an expanding market for the smartphones, and machine-to-machine, M2M data requirements are also going to go up. Ironically, I suspect this market is actually going to flatten out and not go to zero. And the reason that I don't think it's going to go to zero is because there are an awful lot of people who simply don't like smartphones, okay? And they just want a phone that will just do phony type things. Okay, but the market for the smartphones is definitely going to go up. You can't go anywhere these days without seeing a smartphone. You get on a train and everybody's playing with them. And likewise, machine-to-machine data transfers are going to go up as well. This is based upon Cisco 2014 stats. Okay, so here we've got in terms of the data connections for wireless networks, we've got the three current standards, 2G, 3G, and 4G. Clearly, the 2G is going to die because it doesn't carry enough information. 3G is still going through its growing phase. 4G is beginning to increase, but the costs involved are actually quite high, so they haven't taken off as far as they should do. But now, of course, we've got 5G kicking in there as well. So, and that means that we're going to get, as I believe, terabits of information being traversed from one machine to another machine. So these are the market trends in terms of communication. We then have, if we look at the resolution market, there are a whole bunch of these things. I'm actually still down here. I've got a TV at home that fills half the living room because it's a CRT. Maybe one day I'll spring for an HD or something, but these all have massive data requirements. Well, sorry, these above have massive data requirements. Now, I think personally that this market here, the 8K, is probably not going to be for the home user. Probably 4K is going to be the maximum. Not because people don't want 8K, it's probably because you can't resolve it. Okay? The human eye can't go to too high a detail. So if I just skim through these, okay. So as I say, the standard PAL has about half a meg of pixels per second, okay? Whereas if you're looking at the 8K resolution, you're looking at 48 gigabits of information per second, which is absolutely enormous. The only way you can possibly transmit that is by compression, which of course you can do on the chips themselves, the core series and the atom series. And even then it's it's 500 megabits, okay? It's a half a gigabit of data per second, which is huge. There is, It's kind of ironic because back in the 90s, the UK government certainly said that they expected every household to be fully connected within 10 years, and they still aren't. And even then, you're lucky if you can get more than 20 megabits connectivity. And as for 500 megabits a second or 10 megabits a second, no chance, not for the foreseeable future. But there are also those that say that by 2020, we will actually have ultra-high D channels worldwide, and they'll raise from roughly 200 to 1,000 by 2025. Okay, that's quite an expectation, to say the least. And of course, the various areas of which we're interested in, of course, we're on the train, mobile video, live TV. We want to broadcast things. More and more companies are actually streaming data through copper or fiber optic. The video-enhanced online experience. One is shopping. I've actually got another one. I've got an example coming up in a little bit, which might be of some interest. Again, that one's tied into video conferencing. And of course, you've got the cloud-based services that that people seem to want. So the video is a challenge, and in order to get to use it, okay, you've got the various formats, your usage, your codecs, all that kind of stuff, but you need to be able to encode and decode, transcode, video feed, media, whatever. By the way, encode, obviously, and decode, we know. Transcode means conversion from one format to another format. Again, we come back to our happy little chip. Here we've got, again, the CPU part. Okay, and on the same piece of silicon, we've then got a graphics unit. Now, the advantage of this is that you can actually get 300 times encode at 10% of the power. Okay, in terms of laptops, for instance, and battery usage, that's a massive, massive saving. So the more you can actually put through the graphics unit, the longer your battery life is going to be. Okay, so as I said, I thought the graphics units only came on the 4th generation Intel cores, the Core i5, Core i7, but apparently they've actually been in since 2010 in the second generation Intel core. Okay, and of course the speed up of these things is getting pretty impressive. So it's a factor of 75 times over what it was back in 2006. That's just that slide again. Okay, the application, one of the applications that is close to my heart was a project I worked on in the past. I don't know if anybody's heard of Access Grid at all. It's much, much more than a video conferencing environment because it allows interactivity between various sites. You can have loads and loads of separate people in various parts of the world, all talking together with HD cameras. It also allowed for projects to be run, certainly between Cardiff University and Chicago University, to run virtual anatomy sessions. This is just a simple slide. It's a bit blurry on the right-hand side here because this is a stereoscopic image. And the advantage of this environment was that you could actually rotate these things and interact with them and interact with the people over in Chicago. But the bottom line is both of these things were actually being run across 100 meg links. And the resolution, okay, some of it's done in high def, but a lot of it isn't. And in the future, this is going to be... Sorry. And in the future, a lot of teaching is going to be done remotely. And so these kind of environments, immersive environments, this room, by the way, where there's this station would cover the entirety of this wall. So you're going to need much, much better processing power for the future. So some technical things then we need to get through. Okay, it's actually from the second generation Intel chips, but it's also the current versions are on the 4th generation Haswell cores. and Atom processors, which means that you're on your standard laptops and your tablets. The H.264 standard is the high definition standard, as I understand it, for HDTV. There is enhanced support for Windows and DirectX. Of course, then you've got the standard hardware implementations of accelerated MPEG encoding and decoding. The other thing is that this actually includes a free licensing and source for integration with open source projects and OpenCL. I must admit, I had to go and check this because I thought the original version was, in fact, free, but they then started costing it as an Intel project. But I've been told, as of yesterday, that it was actually what it was free, so it's a free download. Okay, so the application areas, primary of interest are the transcode, encode, and decode. So we're looking here at live streaming of information. This is going to be a massive one. It's already pretty big, but it's also going to be massive. The visualization of science applications as well as gaming resources is going to be increasingly important as the resolution on the games increase, and they're pretty superb at the moment. And also there's going to be a lot more decode for things like surveillance and analytics and visual understanding. Visual understanding means you take something apart and have a good look at it. Okay, from programmability, it provides for an abstract layer. It's quite a high-level abstract layer, which means that you can do quite a lot with just a few function calls. It's optimized to run on the hardware, but as I said earlier, if your hardware doesn't support the graphics unit on the same piece of silicon as a CPU, then there is a fallback position whereby things can be put into software. Of course, it's going to run a lot slower. It's future-proof. Well, nothing's actually really future-proof. It's the idea is that you can compile once, and Intel have taken the idea that you can build you can build an executable with several pathways through it, so it will match to different architectures, a bit like the SSE and the AVX architectures on the Xeon 5s. Okay, and as I say, these two come together. There's a fallback position whereby if your hardware doesn't support the calls, then you can use a software library version instead. I've just thrown this one in just as a kind of an idea as to what to expect. The important things in terms of libraries, you've obviously got to include a header, mfx video.++.h. From that, the next thing you really need to do is kind of like instantiate an object. Okay, we'll start an object up to run on the hardware. Then you can do various things like query it for the implementation and the version kind of thing. And all this does is says, let's check what the hardware we've got. If it's not supporting the graphics unit, then we will run to the software library. That's all it says. Okay, so what is Intel graphics overview? The overview of the Intel graphics. Well, obviously you've got the processor, the GPU. You've got fixed functionality into the graphics unit. I was going to make a point on this. So yeah, the Media SDK allows you to get direct access to this part of the thing. The transcode stuff means that you can not only process stuff on the GPU, you can also process stuff on the CPU, so then you can transfer information between the two. Then you've got the SDK is part of the Media Service Studio, and you've got various needs. So you've got developer types, you need communications infrastructure, you've got video and software experts, you've got device manufacturers and media services. And then what the development needs is one solution, many platforms. I've outlined a couple here. It works on Linux and Windows under a single SDK. You need to provide the highest quality video performance, and because it's on chip with a CPU, you can get that. And then you've got to have analysis capabilities. What that means is that you can actually visualize your bit streams and encoders, and you can actually analyze your video streams totally. I think it also comes with VTune. Okay, that's a bit short and sweet, but okay. Any questions? No? Okay. Thank you very much. Video editing, processing, meeting conversion, streaming, playback, and video conferencing. The kind of stuff is very, very prevalent at the moment. And of course, we're going to get a higher and higher demand for this stuff as we require higher and higher resolutions on screens and so on and so forth and devices. The definitions then, just very briefly, we all know these pictures. What is media? Well, clearly it's going to be pictures, video, movie, and audio. There's about 30 slides, but some of them I'm just going to simply skip over as everybody knows what I'm talking about kind of thing, okay? So let's do a bit of background. The Intel Media SDK, it comes as part of the Media Server Studio. It's a cross-platform application interface, and of course it's for developing things like consumer professional media applications, your obvious video. My name is Roger Philp. I work for Baincore. It's an Intel professional services partner of Intel, rather, sorry. This is Manuel Fernandez. Another of our speakers will be here on Thursday, which will be Richard Paul. So this one is going to be, it might be slightly misrepresented in the notebooks, but it's actually about the Intel Media SDK and why it's of use to you. Okay, it's bandwidth requirements, trying to eliminate things like jitter, reduce latency times, and of course loss during transmission. But one of the most remarkable things is that we've actually had quite a high-speed bandwidth across the world for 50 years now, being TV, which has that transmits at roughly about a half a megapixel per second. Okay, the reason why we're looking at it, the various types, the MP1, MP2, MP3. I don't know if anybody's ever, or like the video, if you ever dug through the headers from the MPEG stuff. It's more of a philosophy than a design specification. There are going to be obviously special considerations for media delivery over networks. Networks can be either fiber, copper, or radio, and there's going to be an increasing demand for high bandwidth